For centuries, we've all looked up at the stars and asked the same question. Maybe the biggest question we have: are we alone? We've scanned the skies. We've listened for whispers in the static. We've even sent our own messages out into the great, silent dark. And in 2025, the James Webb Space Telescope might have just given us the beginning of an answer. For the first time in the history of our species, we have an actual photograph of a world orbiting another star. This isn't a chart. It's not a dip in a line on a graph. It's not a clever inference. It's a picture, an image of another world. What you are about to see is a discovery that shifts our place in the universe and kicks open the door to a new, thrilling chapter in the search for life. The impossible challenge of seeing a ghost. Before I show you this image, you have to understand why, for so long, this was considered basically impossible. Taking a direct picture of a planet outside our solar system is one of the biggest technical challenges we've ever faced. The problem is easy to say, but incredibly hard to solve. Stars are bright, and planets are just ridiculously, fantastically dim. Imagine you're in New York City, and you're trying to spot a single firefly buzzing next to a giant, blinding lighthouse beacon all the way over in Los Angeles. That's what we're up against. The star is 1 billion, sometimes 10 billion, times brighter than the little planet orbiting it. The planet's faint, reflected light is completely washed out by the star's glare, like a speck of dust in a hurricane of light. This is why, for decades, we had to find planets indirectly. We became cosmic detectives, looking for clues instead of seeing the culprit. The most famous trick is the transit method, what the Kepler telescope used. You just stare at a star and wait for its light to dip by a tiny, almost unnoticeable amount. That dip is the shadow of a planet crossing in front. It's a brilliant method, and it's how we've found thousands of planets. But the planet's orbit has to line up perfectly with us for it to work. Then there's the wobble method. As a planet orbits its star, its gravity pulls on the star, making it wobble just a tiny bit. By measuring that wobble, we know a planet is there. Again, it's a genius indirect method that tells us a planet exists, but it doesn't show us the planet. These methods gave us a census, a catalog of worlds we knew were out there but couldn't see. There were ghosts in the machine. We knew about rocky super-Earths, massive gas giants, and weird ocean worlds, but they were all just phantoms in the data. To really know them, to check their atmospheres for signs of life, we had to do the impossible. We had to see them. And to do that, we needed a new kind of eye on the universe. The ultimate eye on the sky. And that is where the James Webb Space Telescope comes in. From its perch 1 million miles from Earth, Webb was built specifically to solve this problem. Its power comes from 3 key things. Its giant mirror, its ability to see in infrared light, and its secret weapon-on instrument, called a... First, that mirror. At 6.5 meters across, the golden honeycomb is the largest mirror ever sent into space. A bigger mirror is like a bigger bucket for catching light. This massive collecting area lets Webb see the faintest, most distant things in the cosmos with a sensitivity older telescopes could only dream of. Second, its vision. Webb sees the universe mainly in infrared. This is a game changer for 2 reasons. 1, young, newly formed planets are still warm, and they glow with their own heat in the infrared spectrum. This means Webb isn't just looking for a faint reflection, it's looking for a faint, glowing ember. And on top of that, stars are actually a bit dimmer in infrared light, which helps dial down that overwhelming glare. But the real magic, the key that unlocked this whole thing, is it's a tiny, perfectly engineered mask inside the telescope that has one job: to block the light from the star. It's like putting your thumb up to block the sun. By sliding this mask right in front of the star's image, Webb creates its own tiny, artificial eclipse. It cancels out the glare, and suddenly, the faint little worlds orbiting it can finally step out of the shadows. It's an incredibly delicate dance. The telescope has to hold perfectly still to keep the star hidden, while those few faint photons from the planet, after traveling for more than 100 years, land on its detector. For years, this was just a theory. In 2025, Webb made it a reality. The first photograph, the target was a young star named JWST, about 111 light-years away. It's just a baby star, which makes it a perfect place to look for young, warm planets that are still glowing from their formation. Astronomers had a hunch something was there. They'd seen a gap in the dusty disk around the star, a telltale sign that a planet's gravity had plowed a clear path. Using its mid-infrared instrument, Webb pointed its golden eye at JWST. The coronagraph slid into place, casting a tiny shadow on a distant sun. The telescope just stared, patiently gathering light, photon by photon. And then, after all the processing to clean up the image, there it was. A single, faint point of light. A world. The planet, named TWA7b, is the first exoplanet directly imaged by Webb. It's a gas giant, similar in mass to our own Saturn, orbiting right inside that gap in the disk. It might not be a rocky, Earth-like world, but that doesn't make this any less of a giant leap. What makes this so huge is the door it opens. TWA7b is about 10 times lighter than any exoplanet we had ever directly imaged before. Previously, we could only get pictures of enormous superjupiters, because only they were big enough and bright enough to spot. By imaging a planet the size of Saturn, Webb just smashed through that wall. It proved it can see smaller, fainter, and much more interesting worlds. And this isn't just a pretty picture, it's a treasure trove of data. By analyzing that single point of light, astronomers can start to figure out what TWA7b's atmosphere is made of, its temperature, its chemistry. We are no longer just counting planets. We're getting to know them. The old methods were like hearing a whisper from the next room. This is like opening the door and finally seeing who's there. This one image paves the way for the ultimate goal. To one day take a picture of a small, rocky planet like ours and check its air for the telltale signs of life. Rewriting the history of the cosmos, as if taking the first photo of a new world wasn't enough. 2025 was also the year Webb completely rewrote the first chapter of cosmic history. While one part of the telescope was looking at our relatively close neighbors, another part was staring deep into the past, all the way back to the dawn of the universe. And what it found there was just as good. For decades, astronomers have been in a race to find the oldest, most distant galaxy. In 2025, Webb didn't just break the record, it shattered it. Astronomers announced they'd spotted a galaxy candidate called MAMZ. The light from this galaxy is so ancient, we're seeing it as it was just 280 million years after the Big Bang. Let that sink in. The universe is 13.8 billion years old. We are looking at a collection of stars that existed when the universe was only 2% of its current age. It's the oldest thing humanity has ever seen. Around the same time, another team confirmed the galaxy JWST 1321 existed just 330 million years after the Big Bang. And these aren't just fuzzy blobs. They are structured galaxies, already blazing with new stars, at a time when we thought things were just getting started. But this created a new mystery. How were they so bright, so early? Our models said the early universe should have been filled with a thick fog of neutral hydrogen that soaked up most of the light from the first stars. But Webb showed that the fog wasn't burned off by a few huge galaxies. It was a group project. Webb found dozens of small, faint, starburst and dwarf galaxies all over the place. These little guys were the real engines of reionization. They acted like a swarm of cosmic lighters, each one a tiny pinprick of light, working together to burn off that primordial fog and light up the universe for the first time. Webb's data showed these little galaxies were super efficient at pumping out the exact kind of energy needed to clear out the hydrogen. It was a huge aha moment that finally solved one of the biggest puzzles in cosmology, what it all means. So, what does this all mean? In a single year, Webb delivered history-making discoveries at both ends of the cosmic ruler. On one hand, we have the first intimate portrait of a planet next door. The picture of TWA7b turns exoplanets from abstract ideas into real places. It's the first step on a road that could one day lead us to a world with clouds, oceans, maybe even a biosphere. The search for life is no longer just philosophy. It's a science we can actually do. On the other hand, we have a brand new picture of our own cosmic roots, finding galaxies like MAMZ14 and solving the reionization. Mystery gives us a stunning look into the universe's baby pictures. We're watching the cosmos come alive, seeing the very first sparks that started the 13.8 billion year journey that eventually led to us. The discoveries of 2025 are a monument to our own curiosity. We built a golden eye, a time machine, sent it 1,000,000 miles away, and asked it to look back to the beginning of everything and out at the worlds around other suns. We asked it to show us things we thought were impossible to see, and it delivered more than we could have ever imagined. 2025 is the year our picture of the universe changed forever. We took the first direct photo of a Saturn-like world, opening a new frontier in the search for life, and we peered back to just 280 million years after the Big Bang, witnessing the cosmic dawn itself. But the most exciting part, we're just getting started. The telescope has decades left to go. As incredible as these discoveries are, they're just the opening act. What other worlds are out there, waiting for their closer? What other secrets are hiding in the dark at the beginning of time? If you want to stay on the cutting edge of what Webb reveals next, make sure you subscribe and ring that notification bell. And if this journey was as mind-blowing for you as it was for us, hit that like button to help share these incredible discoveries with more people. Thanks for watching.